Hello and welcome back to my channel. In this video we are going to learn trigonometry basics. Now trigonometry is a branch of mathematics that deals with different types of triangles. So they can be acute angle where the angle is less than 90 degree, or it can be obtuse angle where the angle is in between 90 to 180 degrees, or they can be right angled triangles where the angle of the triangle is exactly 90 degrees. So in this video we are going to learn how to name the sides of a right angle triangle and how to find the angles and how to find the trigonometric ratios, the very basics of trigonometry. Now you might be wondering, where do we use the trigonometry? Trigonometry is used in branches of engineering, in architecture, where you have to find the height of a building, or you have to find out at what angle the monument or the building has to be made, and this can be used to find out the distance between two buildings or two poles and so on. I will be covering the applications of trigonometry in forthcoming videos, but here to learn the applications you need to know the basics first. So in this video I will try to make your basics in trigonometry strong. Now starting with labeling the sides of a right angled triangle for a given angle. I have drawn some right angled triangles here. They are right angled triangles because you can see the angle between the two lines is 90 degree, and for the 90 degree we usually put a symbol showing that there is a 90 degree angle between these two lines. Now we have to label the right angled triangle. What does labeling mean? Labeling has three things to know. Now the first side we can write or label it is the hypotenuse, followed by the second label called as opposite, and finally the third side will be labeled as adjacent. Now these are the three labels we have to assign to all the sides of a given right angled triangle. Now here I am going to use the letters H for hypotenuse, O for opposite, and A for adjacent. Let us look at the first right angled triangle. Now let me give the name here as A, B and C. Now how do we mark the hypotenuse, the opposite and the adjacent? Remember, always start by marking the hypotenuse first. That will make the things easier. So here hypotenuse is the longest side of a triangle, and it is always opposite to the 90 degrees present in the triangle. So here is our 90 degrees, and opposite to that is the side AC, and it is the longest side of the triangle as well. That is why I will name this side as hypotenuse H. So first side is completed. Next we have to mark the opposite side. To mark the opposite side we have to look the angle of concern. Now that means if I am saying, okay, alright, find out the angle C, that means this is the angle of concern, and the side opposite to this angle is AB. So this becomes, AB becomes the opposite side. So the second side is also marked. Now the remaining side, that is BC, can be automatically written as adjacent. So this is the hypotenuse, this is the opposite, and this is the adjacent. Now let me change the angle of concern for the same triangle. So let me take angle A as the angle of concern. Remember, the angle of concerns can be only the acute angles, not the right angle. So angle A and angle C are the acute angles here. So we can take either angle C or angle A to find out what is the opposite, hypotenuse or adjacent side. Now as we know, we have to always start with the hypotenuse first. So we know that hypotenuse is again the longest side and it is always opposite to 90 degrees. So the hypotenuse is not changing in this case. AC will remain as the hypotenuse. Now comes the opposite. Now for the opposite we have to look at the angle of concern. So here I have taken angle A as the angle of concern, and the side opposite to that is side BC. So this becomes the opposite side now. And the remaining side, that is AB, can be automatically taken as the adjacent side. Now let us look at another triangle, that is triangle, for example I'll give the name as P, Q and R. Now in this case, let me take angle P as the angle of concern. So right now we have to first start with the hypotenuse, and we know that hypotenuse is the longest side of a right angle triangle and it is always opposite to the 90 degrees. So this is going to be our hypotenuse. So PR is hypotenuse. Then hypotenuse is completed. Then we proceed to mark the opposite. Opposite is always opposite to the angle of concern. So angle P is over here. So opposite to that angle is side QR. So this becomes the opposite side, and the other side becomes automatically the adjacent. So this is how we label the sides of a right angle triangle for any given angle. Let us try a different triangle now. Let me give the name here as MON. Now looking at this, we can say that this is the right angle triangle. Now we have to mark the angle of concern here. So let us take angle N as the angle of concern. So after that we start marking the first side, which is the hypotenuse. So as we know, hypotenuse is always opposite to 90 degree. So this is the hypotenuse. Then we go on to mark the opposite side, and opposite is always opposite to the angle of concern. So this becomes the opposite, and the remaining side ON becomes the adjacent. Now in this triangle we can see that the 90 degree has been made by these two lines, and these two are the acute angles. So let me take the first acute angle and show here. So first let me name it. So I will give it the name as LMN, and I will take the angle of concern here as N. So again, first we'll start marking with the hypotenuse. Since this is the 90 degree, the side opposite to it is MN, so this becomes hypotenuse. Now angle of concern is N, so opposite side is LM, this becomes opposite, and the other side is automatically the adjacent. Now let me change the angle of concern over here. Instead of N, I will take M as the angle of concern. So let us see how the things change. So let us take M as the angle of concern. Now as we can see that hypotenuse is not changing again, it remains the same. It is opposite to the 90 degree. Now since this is the angle of concern, the side opposite to it is LN. So this becomes the opposite right now, and this remaining side LM becomes the adjacent. So it is quite easy if you follow these steps. Start with marking the hypotenuse first, then the opposite, and then the adjacent side for a given angle. Now after understanding the triangles, how to mark the or label the triangles, we will proceed on to the trigonometric ratios of acute angles. This is a very important and basic topic in the trigonometry. There are basically three major trigonometric ratios. They are given by the names sine, cosine and tangent. So these are the three names of the basic trigonometric ratios. The abbreviation we use for this is sine is written as sin, cosine is written as cos, and tangent is written as tan. Now they also have their reciprocals as cosecant, which is a reciprocal for the sine and abbreviated as COSEC or COSEC, and the reciprocal of cosine is secant, which can be represented or abbreviated as sec, and the reciprocal of tangent is cotangent, which is represented as cot. So remember, if sine is given, its reciprocal is cosecant, cosec. If cosine is given, its reciprocal is sec, and if tan is given, its reciprocal is cot. Now how do we use these trigonometric ratios in finding out the values of the triangle? Now this is a small triangle I have drawn over here. Let me name it as A, B and C, and B is a right angled triangle. Now let me take the angle of concern as C. Now I want to write all these trigonometric ratios in terms of sides of this triangle. After we mark the angle of concern, now we are going to mark the hypotenuse, the opposite and the adjacent. So starting with the hypotenuse, I think you might have already guessed it has to be AC because it is opposite to the 90 degrees. Then opposite is AB because it is opposite to the angle C, and the remaining side is the adjacent A. Now how do we connect this right angle triangle to the trigonometric ratios we have written above? Let me start with the first one, that is sine. We use the abbreviation, so sin, of the angle of concern. So the angle of concern here is C. So sine C is equal to, it's always written as opposite over hypotenuse. So we usually write the abbreviation as SOH. So S stands for sine, O stands for opposite, and H stands for hypotenuse. So this is your first trigonometric ratio. Now here in this triangle, the opposite side is AB and the hypotenuse is AC. Our first trigonometric ratio is completed. Now let me move on to its reciprocal, that is COSEC. So since I said it is the reciprocal, so we can write it as COSEC C, because again the angle of concern is C, is equal to, I'm going to reciprocate it. Reciprocate it in the sense, whatever is there I'm going to flip it. So H, which was in the denominator, now becomes the numerator, and O, which was the numerator, now becomes the denominator. This is what reciprocation means. So here it becomes AC over AB. We do not have any abbreviation like this for the reciprocals. Only for the main trigonometric ratios we do have. These are the three main trigonometric ratios. So for sine we have the abbreviation as SOH. Now let me move on to the next one, which is the cosine. So cos, again we are going to use the abbreviation cos of the angle of concern, which is C. It's always given as adjacent over hypotenuse. So here it is written as CAH. C stands for cos, A stands for adjacent, and H stands for hypotenuse. It is easy to remember the abbreviation when you are using it when solving the examples. So remember the things which I am going to put in the box. So here adjacent is the side BC and hypotenuse is the side AC. Now let me take its reciprocal. The reciprocal of cos is sec. So SEC, sec of angle of concern C, is equal to, I am going to reciprocate this, so it becomes hypotenuse over the adjacent. So the sides become AC over BC. As I said, there is no abbreviation for this. We will leave it as it is. Now comes the fifth one, which is tan. So tan C is equal to, tan is always written as opposite over adjacent. So it has an abbreviation which is TOA, TOA. So we can just put it in a box again. And in this triangle, O stands for AB and adjacent is nothing but BC. Again, its reciprocal is nothing but the cot. So we are going to write here as cot of C is equal to, it becomes adjacent over opposite, reciprocate this, so the side becomes BC over AB. So these things, if you remember the trigonometric ratio basics for acute angles, then it becomes really easy to solve any questions related to these right angle triangles, finding the angles or finding the sides. So remember these SOCA TOA as well. It's going to be really helpful. SOH, so sine equals opposite over hypotenuse, CA, cos equal to adjacent over hypotenuse, and TOA, tan equal to opposite over adjacent. So do remember this abbreviation. Now with the basic understanding of these trigonometric ratios, let us start solving some examples. Finding trigonometric ratios. So they will ask you to find 6 trigonometric ratios using the 3 sides given for a right angle triangle. Sometimes they will ask you only sine, or they can ask you only cos or tan, depends. But here we are going to find out all the 6 trigonometric ratios. Now here you can see they have not given us which angle to consider. So I will show you for both the angles how to do it. Let us consider angle C as angle of concern. So first one we will start with sine C. So before we could proceed with this, we have to write which is the hypotenuse, which is the adjacent, and which is the opposite. So here this is the right angle triangle, so opposite to this is 5, So this becomes our hypotenuse. So AC is hypotenuse. Now angle of concern is C. So the side opposite to it is 4. So this becomes our opposite side. And finally 3 is going to be automatically our adjacent side. Now sine, we know that it is always going to be opposite over hypotenuse using this so. Now here our opposite side is 4 and hypotenuse is 5. That is it. We have found our first trigonometric ratio. Now immediately go for its reciprocal, which is COSEC. COSEC C is going to be hypotenuse over the opposite. So I'm just going to reverse it. It becomes 5 over 4. You have got your second trigonometric ratio. Coming to the third one, we have CA, that is cos. So cos of C is equal to adjacent over hypotenuse. Here adjacent is 3 and hypotenuse is 5. We got our third trigonometric ratio. So immediately go for its reciprocal, which is sec C is hypotenuse over adjacent, which is given as 5 over 3. Just reciprocate whatever you got. Fourth trigonometric ratio is also completed. Now the fifth one, which is TOA, tan. So tan C is equal to opposite over adjacent. So opposite here is 4 and adjacent here is 3. Finally we have the reciprocal of tan, which is cot C. So we are just going to reciprocate it, A over O, and it becomes 3 over 4. So angle of concern was C. So with respect to C, we have got all the 6 trigonometric ratios. Now let us change the angle of concern from C to A and see what we will get. So let me just erase some things from it. Okay, so this is erased. Now let us see with respect to angle A how our opposite, adjacent and hypotenuse changes. Now hypotenuse is not going to change because it is still opposite to angle B. So this is our hypotenuse. Now opposite has changed. Now angle A is over here and the side opposite to it is 3. So this is the opposite, and now 4 has become the adjacent, the remaining side. Now let us check for sine A. Remember, these ratios are not changing. It still remains as SOHCAHTOA. So for sine A, it is opposite over hypotenuse. Now opposite has become 3 and hypotenuse is 5. Now cosec A, we are just going to reverse it, 5 over 3. Now cos A is going to be adjacent over hypotenuse. Adjacent is 4 and hypotenuse is 5. Now sec A, just reciprocate it and you get it as 5 over 4. Now tan A is opposite over adjacent. Opposite is 3. Adjacent is 4. So cot of A becomes 4 over 3. That is it. So this is all you have to remember, finding the trigonometric ratios. It is a very basic foundation you have to remember, because if you remember this, the applications of trigonometry examples become really easy for you to solve. Now let us look at the next example. Here we can take the angle of concern as Q. So first we will start by marking the hypotenuse. So SQ is the side opposite to the 90 degrees. So this is the hypotenuse. 5 is the side opposite to the angle Q. So it becomes the opposite. And 12 becomes the adjacent. Now they have asked us to find all the trigonometric ratios. But in this case, the value of hypotenuse is not given. To find out the sides, you have to remember that we have to use the Pythagoras theorem. Pythagoras theorem. So the Pythagoras theorem states that the hypotenuse squared is equal to the sum of square of the rest two sides. So hypotenuse square is equal to opposite square plus adjacent square. Now since we do not know the hypotenuse here, so we'll keep the hypotenuse as h square equals O is the opposite and opposite is 5, so it becomes 5 squared plus adjacent is 12 squared. So we have it as 25 plus 12 squared is 144. So we get it as 169. This is our h squared. So if we want to find the hypotenuse, we are going to take the square root of 169, which gives us 13. So our hypotenuse here is 13. Now as you can see, we found out all the three sides. We can easily find out the trigonometric ratios. So remember, if one of the side is not given, then always go for the Pythagoras theorem. And this is how the Pythagoras theorem is written. Hypotenuse square is equal to opposite square plus adjacent square. Now let us start finding the trigonometric ratios, starting with sine Q. Sine Q is opposite over hypotenuse. So opposite is 5 and hypotenuse is 13. Now we will immediately find its reciprocal, COSEC Q. It is hypotenuse over opposite, so we write it as 13 over 5. Then we'll find cos Q. So cos is given as adjacent over hypotenuse. So adjacent is 12 over 13. And its reciprocal sec Q, it is hypotenuse over adjacent, so it's written as 13 over 12. Then comes the last thing, tan of Q is opposite over adjacent, so opposite is given as 5 and adjacent is given as 12, and its reciprocal, which is cot Q. So cot Q is written as adjacent over opposite, which is 12 over 5. So you have got all the 6 trigonometric ratios. So as an exercise, you can try finding angle S as an angle of concern and find out all the trigonometric ratios. Now let us look at finding the trigonometric angles. In the previous case, we were just finding the ratios, the trigonometric ratios. Now we are going to find the trigonometric angles. Find x in the following examples. So x is the angle of concern here. So we need to find out the angle x. Remember, before we find out the angle x, we have to mark again the hypotenuse, the opposite, and the adjacent. So we are going to start with marking the hypotenuse first. So this is the right angle triangle. So 6 becomes the hypotenuse. Now x is the angle of concern and the side opposite to that is given as opposite, and the other one is given as the adjacent. Now to find out the angle of concern, that is the x, look at the sides which are being given in the triangle. Here they have given adjacent and they have given the hypotenuse. So let us first see if we can use the so, that is the sine. If we are going to use the sine to find out the angle x, we need to have the opposite. Here the opposite side is not given. So since we do not have the opposite, this is not a correct choice to find out the angle x. Next, let us see at ka. Ka is cos, adjacent, and hypotenuse. So here, as we can see, we have the adjacent and hypotenuse. This could be a correct choice to find out the angle x. So we can write here as cos of x degree is equal to adjacent over hypotenuse. So here we can write cos x is equal to adjacent is given as 4 and hypotenuse is given as 6. Now they have told us to find the x value. So we write x is equal to, now this cos we are going to take on the other side. So cos changes to cos inverse, or we also call it as arc cos. So in this case I am going to call it as cos inverse of 4 over 6. We have to use calculator to find out the value of cos inverse of 4 over 6. So let us use the calculator now. So for finding the cos inverse, you have to click on the shift and then click on the cos. You can see you over here you get the same exact sign, cos inverse 4 divided by 6. So you get the answer as 48.18 degrees, or you can round it off as 48.19 degrees. So this is the value of x. Another way to solve it is you can obviously find the third side by finding the Pythagoras theorem, and then at that time you can use the sine, or you can also use the tan. So let me show you that way as well. So let us take here the third side which we have to find using the Pythagoras theorem. So using the Pythagoras theorem we can write here hypotenuse square is equal to the opposite square plus the adjacent square. Now hypotenuse is 6 here, so 6 square is equal to opposite we do not know, so opposite square plus adjacent we have it as 4, so 4 squared. Now 6 squared is 36 is equal to opposite squared plus 4 squared is 16. So we take 16 on the other side, it becomes opposite squared is equal to 36 minus 16, which gives you 20. So opposite is equal to square root of 20. So let us see how much is square root of 20. We have square root of 20 as 2 root 5, or change it to decimals, giving it as 4.472. So we have it as 4.472. Now here we have our opposite as 4.472. Now we can use the SOH, that is SOH. Sine of angle x is equal to opposite over hypotenuse. Opposite we got it as 4.472 divided by the hypotenuse, which is 6. Now we are going to take the inverse again. So x is equal to, sine should be taken on the other side, so sine turns into sine inverse. So sine inverse of 4.472 divided by 6. So let us check what answer we get. Again, make sure that the calculator is on the degrees. So we take shift of sine inverse and we get it as 4.472 divided by 6. So we get it as 48.18. You can see the previous method also we had got the same answer as 48.18. So whichever method you use, you are going to get the same answer. Here if you decide to use the tan of x also, it's also going to give you 48.18. So no matter if you are using sine, cos, tan, any of the methods, it will all give you the same answers. Let us look at the next one. Here the angle is over here. So first we start by marking the hypotenuse. So here we can see the hypotenuse is over here. And this is going to be the opposite. And this is going to be the adjacent. Now we have to find the angle x. I will advise you not to waste your time finding the hypotenuse, because as much as possible you will be able to get the answers using the SOHCAHTOA for finding the angles. So here let us check with the first one, which is SOH, that is sine, opposite and hypotenuse. Now sine of angle x, opposite it is with us, but hypotenuse is not given in the question. So no point in taking the sine. Let us check with the CA, that is the cos, adjacent and hypotenuse. Now cos of angle x equals adjacent, which is given in the question, but again the hypotenuse is not given, so we will not take the CA. Now let us check with the TOA, tan, opposite and adjacent. Now tan of x equals adjacent, it is given in the question, as well as the opposite is given in the question. So it is a good choice to make. So let us write tan of angle x is equal to opposite over adjacent. So tan of x is equal to, the opposite is given as 4 and the adjacent is given as 12. Now to find the angle x, we take the tan on the other side, so it becomes tan inverse or arctan. So tan inverse of 4 over 12. Let us find it out in a calculator. How much is tan inverse of 4 over 12? So here shift tan. So we get tan inverse 4 divided by 12. So we get it as 18.43. So the angle x is here 18.43 degrees. Make sure that the calculator is on degree mode, not on the radians, the answer will change if you are keeping it in the radians. So make sure that it is in the degree mode always for these questions. Now let us look at the next one, which is finding the missing sides. Find x in the following examples. Now x is a side here and angle of concern is 55, which is given. Again we will start by marking the hypotenuse first. So this is the 90 degree, so opposite to it is the hypotenuse. This is 55 degree angle of concern and opposite to that is 29, so this is 29, which is opposite, and x is our adjacent. And in this case we have to find the adjacent. So we have to start again with SOHCAHTOA. So let us see if we can use the SO. So if we are using the SO, that is the sign, we need the opposite, we have the opposite, and we need the hypotenuse. But here there is no point finding out the hypotenuse because they are asking us to find the adjacent. So this can be rejected. Let us check with CA, that is cos. If we are using cos of 55, we have the adjacent which we need to find, yes, but we also need the hypotenuse, which is not given in the question. So here you will be left with two unknown variables, so it will be very difficult to find the adjacent. So we can skip the CA as well. Now finally comes the TOA, that is tan of opposite and adjacent. Now if we are taking TOA, that is the tan, we can write it as tan of the angle of concern, which is 55 degrees, is equal to opposite over adjacent. So here we have tan of 55 equals, opposite is given as 29 and adjacent is given as x, which we need to find in this example. So here the x and tan 55 exchanges place. So x comes over here and tan 55 exchanges and comes to the place of x. So we can write x equals 29 divided by tan 55. So this is basically your basic mathematical operations. Division becomes multiplication and multiplication becomes division. So let us see what we get the value of x here. So let's check 29 divided by tan of 55. So let's see what we get, 20.30. So we have it here as 20.30. So this is the side. So we can say 20.30 units or just 20.3 because x is a side. Let us look at another example. Here again we can start by marking the hypotenuse, opposite and adjacent. As you might have got to know already that x is the hypotenuse because it is opposite to the 90 degree. 47 is the angle of concern, hence the opposite side is this. This is our opposite, and the remaining side becomes the adjacent default. So we have to find the hypotenuse in this case. So let us check if we can use the SO. So if you are using the sign, we need the opposite, which we do not have, it is not given in the question, and we need the hypotenuse, which is also the missing side. So we have two unknown variables here, so there is no point in using the SO. Let us check with CA, that is the cos. So if we are using cos of 47, we need the adjacent, which we have with us, and we need to find the hypotenuse, which is the missing side. So since we have only one missing variable here, we can use the cos. So we can write it as cos of 47 degrees equals adjacent over hypotenuse. So we have cos of 47 degrees equals adjacent is 28 and hypotenuse is x, which we need to find. Again, we have to exchange the places. X comes in the place of cos 47 and cos 47 comes in the place of x. So we can write it as x equals 28 over cos 47. So let us find out how much is this value. So we have 28 divided by cos of 47. We get it as 41.05. So we can round it off as 41.06 units, because again x is a side. So it is 41.06. So this is the way we solve the trigonometric ratios to find the missing sides. Now let us look at the critical thinking questions, which are very popular in your examination. So the examination kind of questions are given here. Now let us look at some critical thinking questions. In a right triangle ABC, measure of angle A is 58 and AB is the side which is given as 8. Find the length of each of the following and round your answers to the nearest tenth. BC. Now BC is the side which we need to find out. This is the side we need to find. Now first we will start marking the hypotenuse, opposite and adjacent. Now since B is the 90 degrees here, so we got to know that AC is the hypotenuse and 58 is the angle of concern here. So BC becomes the opposite and the adjacent is your 8. Now since they are asking you to find the BC, which is the opposite, let us check which one we can use. So let us start with SOH. Now if we are using the sign, we need to have the opposite and hypotenuse. Now we can see the opposite is also not given and hypotenuse is also not given. So this would be not a good option to choose. Now if we use CA, we have the adjacent with us, which is given, but hypotenuse is not there. And here we are supposed to find the opposite side. So there is no point taking the cos, because we can only find the adjacent or the hypotenuse if we use this. So this is also not a great option. Now let us go for the last one, which is TOA, for the tan. Now we have the tan of 58 with us. We need to find the opposite as asked, and we also have the adjacent given. So we can use the tan. So we are going to write it as tan of the angle given, which is 58 degrees, equals opposite over adjacent. So here we have tan of 58 equals, the opposite side is the BC divided by the adjacent side is 8. So to find BC, we are just going to multiply the 8 with tan 58. So BC is equal to 8 times tan 58. So let us see what we get the answer here. We have 8 times tan 58. So we have it as 12.8. So 12.8 is the opposite side. So this is our BC, which we got. Now let us find out AC. Now to find AC there are two ways. One, you can either use the Sokatova method or you can use the Pythagoras theorem. I'll show you both the ways. Now this is my first method. I'll be using So let us see if we can use So for finding the AC. So SOH. Now sine of 58 can be used. Opposite, we just now got it, which is 12.8, and we should find the hypotenuse. So this works well. So we are going to write it as sine of 58 equals opposite over hypotenuse. So here we have sine of 58 equals opposite, we have it as 12.8 and hypotenuse is the AC. So here we are going to exchange the places between AC and sine 58. So AC will be equal to 12.8 divided by sine 58. So let us see what we get. We have here as 12.8 divided by sine 58. So we get it as 15.093. Since they have asked to the nearest tenth, I'm going to round it off to 15.1. So we got the hypotenuse as 15.1. Now let me show you the second method where I'm going to use the Pythagoras theorem. Since I have the adjacent and also the opposite, I can obviously find the hypotenuse. So it's given as hypotenuse squared equals opposite squared plus adjacent squared. So opposite, we have it as 12.8 squared plus adjacent we have as 8 squared. So let us put up in the calculator and see how much we get. We have as 12.8 squared plus 8 squared. So we have here as 227.84. Let's check by taking the square root of the answer. 227.84. So the square root of the answer gives us 15.09, which can be rounded off as 15.1. So as you can see, both the methods give you the same values. So either you can use the trigonometric ratio to find out the values, or you can use the Pythagoras theorem if you have any of the two sides given to find out the third side. Now this is another question. I have kept it as an exercise for you to try. You can give it a try and comment the answers below, whatever you have got. And hope this video was helpful, and if you're liking my videos, please like, share and subscribe to my channel, and thanks for watching.